everyone. I'm Bob Ward, Principal Architect on the Azure Data Team here at Microsoft. I'm excited to be here with all of you for Build 2022. You know, I've been with Microsoft for almost 3 decades. And as much as Microsoft products have evolved over the years, one thing has remained the same. And that's our commitment to really understanding what our customers want to do so that we can help them do it. That's why I'm excited to talk to you today about what we've been up to in the world of SQL. I invite you to join our team with a live Q&A chat during today's session. Or join us immediately after this session for Ask the Experts. In particular, I'm going to talk about how we're making it easier to access and analyze data, as well as maintain data integrity. These are 3 key areas where we've made enhancements to SQL this year. We know that data is always important, but siloed platforms for operational databases, analytics, and governance has been a challenge. And while our individual data offerings stand strong on their own, this is why we brought our database, analytics, and governance services together into a single unified data platform. We've made significant investments within our data platform to eliminate the fractured environments our customers have been facing, which also means more opportunity to fully leverage data in the Microsoft cloud. Let's take a closer look at what we've done and how it will allow you to do more with less effort. Let's start with SQL Server 2022. I'm excited to announce today the public preview of SQL Server 2022. I'm sure if you're watching right now, you just want to download the bits and get started right away. So go to aka.ms, get SQL Server 2022 to download SQL Server 2022 today and start giving us your feedback. We are so excited for everyone to see all the new capabilities of SQL Server 2022 and look forward to general availability later this year. Now let's do a rundown of the major features in SQL Server 2022 and why we believe you will want to upgrade to this release. It all starts with connecting SQL Server to Azure. SQL Server 2022 is now truly a hybrid data platform. It's using Azure SQL Managed Instance for managed disaster recovery. It's using Azure Synapse for near real-time analytics. Or you can integrate with Microsoft Purview for insights, Lineage, and centralized policy management, a true hub for security. SQL Server now connects to Azure on your terms in ways never seen before. Now we know that security is always critical for your data. So not only does SQL Server continue to be the least vulnerable database in the industry, but we are bringing innovative data protection capabilities like SQL Ledger. We also know we don't have an engine if we are not the best at performance and availability. While our record-breaking benchmarks prove we are the leader in price performance, we know we need to provide an engine that adapts to your workload, giving you faster performance with no code changes. That is what built-in query intelligence is all about. You'll hear more about Synapse, Purview, and SQL Ledger later in today's session. It's important to know that as you think about SQL Server, think about it as SQL that is everywhere you need it, edge to cloud, with the same T-SQL language, tools, and core engine. Hey, speaking of benchmarks, maybe you missed the news that HPE recently published a record 100 terabyte TPCH benchmark on a non-clustered system. HP published this record-breaking price performance result using SQL Server 2019 and Windows Server 2022 on their HP Superdome Flex 280 system. Did you know that SQL Server is the only database vendor now with TPCH results in every scaling factor 1 terabyte and above? We believe many of the new capabilities of SQL Server 2022 solve challenges you face every day. And one of these challenges is setting up and maintaining a disaster recovery site. You know, SQL Server has all the features you need to support your disaster recovery requirements, but the burden is on you to set it up, configure, and maintain it. So we believe the link feature for Azure SQL Managed Instance is the solution. You can now link your SQL Server 2022 database to an Azure SQL Managed instance for managed disaster recovery. We use the power of built-in distributed availability groups to easily seed and link your database to Azure. Then, as you make changes, Azure SQL Managed Instance automatically reflects them, just like a secondary replica. Then, if circumstances arise, you can fail over to a SQL instance powered by the Azure infrastructure, fully managed. When your SQL Server 2022 is back up and running, you can just safely fail back. We make the setup and configuration of this simple, and you don't even need an availability group to get started. We just do it all for you. SQL Server 2022 also comes with a vast set of core engine features solving challenges you face for security, scalability, and availability. For security, this includes SQL Ledger and enhancements to encryption to support the latest version of TLS and always encrypted. That's not all. We have security improvements for Linux and new, more granular built-in security roles. For scalability, this includes features like buffer pool scalability to keep you fast on large systems, and system page latch concurrency enhancements to make temp DB workloads just work with no tuning. In addition, we are improving concurrency for your workload and automated statistic updates. And for availability, we are so excited to announce contained availability groups. Finally, SQL Server will handle replicating SQL agent jobs, logins, and linked servers along with your databases. We know this solves a long-standing challenge to maintain high availability with SQL Server. We're also enhancing backups to include the ability to perform snapshot backups and harness the power of technologies like Intel Quick Assist. There are a range of other new features in the engine, including XML compression, multi-write replication, and improvements for accelerated database recovery and parallel redo, just to name a few. In addition, in the engine, we are enhancing our capabilities for data virtualization and object storage to S3 systems, and even T-SQL language enhancements for JSON, built-in functions, and time series. Our public preview documentation has the entire list of new engine features. Now, I want to look at another challenge I've seen across my career with SQL Server, and that's query tuning, which all of you know can be often expensive and time-consuming. We started a journey in SQL Server 2017 to make the query processor robust and adaptable to all types of query workloads. We call this Intelligent Query Processing, or IQP, making your query performance faster with no code changes. SQL Server 2022 includes the next generation of IQP capabilities based on common customer challenges. This includes integration with the query store, our built-in repository of performance statistics persisted in the database. Three common challenges IQP will solve in SQL Server 2022 are query performance issues due to cardinality estimation models, degree of parallelism, and the infamous parameter-sensitive plan problem. In addition, the query store will be on by default for new databases. It will support hints to shape plans without changing application code, and support capturing performance information about read replica queries. Let's dive deeper into all the IQP capabilities in SQL Server 2022. First, when you upgrade to SQL Server 2022, regardless of your DB compat level, you get new features. First, you get approximate percentile, which can help speed up large analytic type queries by giving you an approximation versus having to scan large tables. In addition, you get query compilation replay, which records steps of compilation to help avoid compile storms. Now, we know that trying to determine the best max DOP value for your system, database, or query can be difficult. So we are also including a feature called DOP feedback. Built into the query processor, this feature uses a feedback loop to make processing those workloads a lot smoother, including adjusting max DOP for certain queries with no recompile required. In addition to these features, if you're using DB compat 140 or later, you get more. If you remember, one of the things we did in SQL 17 and 19 was a feature called memory grant feedback. So in SQL Server 2022, if you're using DB compat level 140 or above, we have enhanced this capability with memory grant feedback percentiles, improving the algorithm for when memory grant feedback is used. In addition, memory grant feedback information can now be persisted across planned cache eviction or server restarts. In addition to both of these areas, if you are using the new DB Compat 160, you get two more capabilities. The first is parameter-sensitive plan optimization. Can we finally save the world from parameter sniffing? The engine can now cache multiple plans for the same stored procedure based on statistics and parameter values. The second is cardinality estimation feedback. You've told us that in some cases, you are forced to use the legacy cardinality estimation model for your database or queries. Now the query processor can automatically apply query hints based on a feedback mechanism known as CE model query patterns. All of these capabilities are built into the query processor, but some of them require the query store to be enabled to take effect. And hey, don't forget, if you're using DB Compat level 140 or greater, you also get previous generations of IQP enhancements from SQL Server 2017 and 2019. The next gen of IQP in SQL Server 2022 is packed with new capabilities you need to solve common query performance issues with no code changes. But I'm sure at this point you're thinking, I want to see some demos. So let's take a look at two IQP examples in SQL Server 2022, parameter-sensitive plan optimization, and DOP feedback. You can see here I'm running SQL Server 2022, and I've loaded the Wide World Importer sample database. I've also created a stored procedure that gets stock items by supplier IDs. The supplier ID is a parameter to the stored procedure and use an aware clause to get stock items for a given supplier. So what I'd like to do is see the stored procedure in action. I'll run the stored procedure and pass a supplier ID of 2. For this specific supplier ID, an index seek is chosen because there are a few rows for that given supplier ID. And I'll see from the overall performance that this query takes no more than about 20 milliseconds or so to run. On the right-hand side, I'll simulate plan cache eviction, and I'll run the same stored procedure with the parameter value of 4, a supplier ID of 4. And now I'll go see what the performance is of this procedure and what plan is used. Because remember, plan cache was evicted. Now, a lot of rows are needed for this supplier ID, so I'm actually using a scan, a clustered index scan, as part of the plan, and even using parallelism to get the rows returned. Now, there's only one plan in cache now, so if I go back and run the same stored procedure as before with a parameter value of 2, you'll see here that it looks like it takes a very fast amount of time to run. And you'll also see that it's using this new plan in cache for a scan. Not ideal, though, for this parameter value. Now, is there an impact on performance? Well, if you scroll down, there sure is. The procedure now runs 10 times slower than before. If this procedure is executed often by the application, there will be an observed degradation in performance. So let's see the impact of an actual workload. Let's use perfmon to observe performance, look at processor time, and batch requests per second. And let's use a tool to observe the workload of the index seek plan, running a procedure with a parameter value of 2, this time with multiple users running concurrently. Then we'll also have a workload for the scan plan. We'll simulate plan cache eviction and run a procedure with a parameter value of 4. So if I kick off the workload, I can see here very quickly that it finishes in just a couple of seconds. Looking at perfmon, I can see a nice throughput with a fairly reasonable amount of CPU time for the workload. Now I'll go back and run the workload for the scan. This should take only a few seconds to run, and once it's completed, I can go back and now run again the workload for the index seek to observe its performance. I will see from perfmon a very telling sign of a degradation in performance. First of all, I can see the throughput of batches have gone considerably down this time around. And I can see processor time has gone significantly high. And the query performs so poorly, I'll have to go ahead and just cancel it. Let's drill a little deeper into the table to see the problem. You can see for supplier ID 2, there are only 3 rows. But for supplier ID 4, there are millions. This represents a skew in statistics and explains why different plans are needed for different parameter values. So how will we solve this problem? Well, in SQL Server 2022, we can set the DB Compat level to 160. Once we set the Compat level to 160, we now have enabled, by default, parameter-sensitive plan optimization. Now let's go see how the workload behaves. I'll run the index seek again, like I did the first time. It'll finish in a few seconds. I'll run the index scan again, simulating eviction of plan cache. It'll finish. Now I'd like to go back and run the first query and see if I get consistent performance. You can see now here the query will finish in a few seconds. This is the performance we expect. If I go into perfmon, I get exactly what I'm looking for. Consistent batch requests per second, consistent use of processor time. This is parameter-sensitive plan optimization. Now let's look at the query store to prove we have two plans for the same store procedure. In one case, I have a plan for index seek. This is using the parameter value of 2. You can see here it's the same query from the stored procedure. I also have another plan for an index scan using the same query for the same stored procedure. Let's look at another IQP feature called DOP feedback. Using the same stored procedure from the previous example, remember that the procedure with the parameter value of 4 uses an index scan, but it also uses parallelism. And on a server with 32 CPUs, if SQL Server is configured to automatically choose parallelism, it could use 32. Now that may not be the most efficient use of resources for this specific query, but more importantly, for the overall workload and the overall system. Customers have struggled for years on what is the right parallelism setting for the server, for the database, and for a query. In SQL Server 2022, by setting a database option DOP feedback, the optimizer in the engine will use the query store to collect information and take feedback to decide what is the optimal DOP setting for any given query. Let's look at how DOP feedback works by looking at a time lapse of execution of this stored procedure using new extended events provided in SQL Server 2022. First, we'll determine is the query eligible for DOP feedback by looking at a suggested time and current DOP setting. Now that the query is eligible, we can lower the DOP without recompiling the query and store this information in the query store. Then a validation process can take place, a feedback cycle, with the query store and the optimizer to decide if the query is performing similar to what it was before, now with a lower DOP. The optimizer will now go through a process of continuing to provide feedback about possible lower DOP values, each time validating that performance was not degraded significantly for the query by using a lower DOP. It is possible to get to a DOP value at some point in this query where the feedback must be reverted back to a previous DOP value, so in order to not have significant degradation in performance of the query. Now let's use the query store to observe performance of this query over time during its feedback cycle. We'll look at the average duration of the query first. You can see as the DOP was adjusted down, the query got faster, finally reaching to a point where the DOP was stable. The duration was also stabilized. Now look at average CPU and you see a similar pattern. You can see the CPU utilization started up at a certain point, and as DOP was lowered, so were the required CPU resources to run the query. Lower DOP, less CPU resources, similar duration to run this query. That's DOP feedback. Well, there you have it. SQL Server 2022 can solve expensive multiple different query performance and tuning problems with no code changes required. It proves that SQL Server has an engine built in to respond to a variety of different query workloads. That is how it works, but what do customers say about it? MSC has many experts in their company that know SQL Server and query tuning. But even they know the value of gaining performance with no code changes. They see the value of the progression of IQP with each release of SQL Server. We look forward to see what MSC and all of you will be able to do with SQL Server 2022 in the future. And don't forget to share your feedback with us. We want to know from you about the value of this new release. Now that you've learned about SQL Server 2022, I want to talk about what we've done with Azure Synapse Analytics and how we're linking it together with SQL technologies. I am proud to announce today the public preview for Synapse Link for SQL, which includes support for both SQL Server 2022 and Azure SQL Database. Customers tell us they want analytics for their SQL operational data, but the challenge is that ETL is typically the solution. That can be expensive, the data is often out of date, and any attempt to execute analytics with SQL Server operational data affects the primary workload. The solution is Synapse Link for SQL, breaking down barriers between operational data and analytics, linking SQL to Synapse seamlessly. But what is Synapse Link? Synapse Link allows you to easily integrate your SQL workloads with a Synapse workspace and dedicated SQL pools. This allows you to get your data faster with near real-time analytics, minimize the need for ETL, and fully leverage the power of Azure Synapse Analytics for a full data warehouse scale solution. You can now freely separate your analytic and operational workloads in a seamless, simple, and integrated fashion. Let's see how it all works. You first deploy SQL Server 2022 in your infrastructure and a Synapse workspace in Azure. Next, you deploy and control a landing zone. This is a storage location in Azure for SQL Server data in a format easily ingested into Synapse SQL pools. Then you set up a link between Synapse and SQL Server using the self-hosted integration runtime. This lightweight agent can run anywhere in your network where it can connect to Azure and your SQL Server 2022 instance. Synapse will communicate to the self-hosted runtime to direct SQL Server on which tables to synchronize with Synapse based on your choices. The SQL Server engine has built-in capabilities to see data from your selected tables of your database into the landing zone. An ingestion service inside Synapse will pull the data from the landing zone into Synapse SQL pools, including schema and data. Once the data is synchronized, the SQL Server engine will continuously harvest any changes related to your selected tables from the transaction log and push them into the landing zone, which then changes the data in the SQL pools. This process can all be guided from Synapse Studio, and all the capabilities are built into SQL Server and Synapse. Since your data is now in Synapse, you can use the full integrated capabilities of Power BI to power your analytics. What about Azure SQL Database? Since the engine is the same code base as SQL Server, the process and flow are the same, but streamlined. Azure SQL Database is a managed service, so Synapse Link is also managed. The landing zone is managed within the Synapse workspace, and Azure SQL Database doesn't need any additional software to synchronize data with the landing zone and ingestion service. And Power BI is there to analyze all your data sources across the Synapse workspace. Let's see an example of how Synapse Link for SQL can provide near real-time analytics with a demo from Chuck Heinzelman.
Thank you, Bob. I'm really excited to be here to talk about Azure Synapse Link for SQL and show how it can help our customers get from data to insights faster and easier. So here's our scenario. Wide World Importers has a very strong online presence, and their data lives in Azure SQL Database. Their business focuses on sales to both distributors and directly to customers. They want to be able to focus more efforts on the direct-to-customer side of the business, so they acquired another company who specializes in working with distributors. The problem is that the company that they acquired has all of their infrastructure running on premises. While they are planning their move to the cloud, that migration is going to take them several months to complete. While Wide World Importers Corporate is willing to work through the cloud migration, they are not willing to wait that long to have a unified analytics platform. Enter Azure Synapse Link for SQL. With Azure Synapse Link for SQL, Wide World Importers will be able to easily combine the data from their cloud-based and on-premises transactional systems into a single cloud-based analytics platform without having to write a line of ETL code for data movement. Let's see this in action. We're here in SQL Management Studio, and we have the two databases that Wide World Importers is using for their transactional systems. One in Azure SQL Database, the other running in SQL Server 2022 on-premises. The databases have matching schemas, but the data in the Azure SQL Database instance is only the direct customers, while the data in the on-premises SQL Server 2022 instance is only the distributors. They want to combine all of this data into a single analytical store. The first thing we need are linked services to our databases. As you can see here, we have a linked service for the Azure SQL Database, and another linked service for the on-premises SQL Server 2022 instance. Since one of our sources is an on-premises SQL Server 2022, the next thing that we need is a storage account to use for the landing zone for data from that instance. You don't need to do this for Azure SQL Database, since we manage that account for you. We also need a self-hosted integration runtime to communicate with the on-premises SQL Server 2022 instance. Again, this only applies to SQL Server 2022 as we manage this for Azure SQL Database instances. The final prerequisite is an Azure Synapse Analytics dedicated SQL pool. This is where all of the data will land. Once we have all of this in place, we can set up the actual link from the source systems. I already have 2 links set up, one bringing data in from the Azure SQL Database instance and one from the on-premises SQL Server instance. When you configure the link, you can specify information about the source and destination tables, including schema, table name, table distribution, and table organization. One of the nice things to note here is that you don't need to create the tables in the target dedicated SQL pool. When you start the link, part of the initial data seeding is the creation of the tables. Since I don't want to make you wait for the initial data seeding, I already have these links running and replicating data into the dedicated SQL pool. Each source database is coming into its own schema, and I'm using views on top of the source tables to union the data from the 2 systems into a single analytical solution. I can run a query over the customer's view to show the split of customer records that are coming from the on-premises versus from Azure SQL Database. You can see here that we have 261 cloud-based customers and 402 on-premises-based distributors. Here's where the magic happens. I'm going to go into the operational databases and add a few customer records to each. I'll add 100 additional customer records to the Azure SQL Database and 50 additional records to the on-premises SQL Server. What is happening now is those records are being replicated automatically from the source systems into the dedicated SQL pool. If I go into Azure Synapse and rerun the query that I ran previously, you'll see that I now have 100 additional customers from the cloud source and 50 additional customers from the on-premises source. Now that the data is in Azure Synapse Analytics, I can switch over to a Power BI report that is currently showing the data from before I added the customers. This report is running in direct query mode, so any refreshes will run queries directly against the data source, in this case, our dedicated SQL pool. If I refresh this report, we will see the updated totals: 361 cloud-based customers and 452 on-premise distributors. In this demo, we've just scratched the surface of the power that Azure Synapse Link for SQL provides. With the move to public preview this week, we are excited for you to try out this new functionality and let us know what you think. Back to you, Bob.
Thanks, Chuck. I love how Chuck demonstrated that you could link data both from SQL Server and the cloud into the same Synapse workspace. We've seen a lot of interest from customers for Synapse Link for SQL, and Atrium's one of them. I love the fact that Atrium discovered they can modernize their analytics systems by greatly reducing their need for complex packages and pipelines. Just link SQL to Synapse and you can achieve near real-time analytics over business-critical data and reduce impact to your operational workloads. It's a great story, and one of the many great stories we expect to hear in the coming months as more businesses take advantage of the public preview. Let's now talk about Azure SQL Database, the fully managed database service perfect for cloud-born applications. Today, we have several announcements for new developer experiences for Azure SQL Database. This includes public preview for a new local developer experience, SQL bindings for Azure Function integration, and new T-SQL JSON capabilities. In addition, we are announcing the private preview of a new HTTPS API endpoint experience built into the SQL engine. And finally, we're excited to announce the general availability of Azure SQL Database Ledger. We see developers across the spectrum use data, and we know that it can be challenging to get seamless access to data that's integrated with other services in today's modern DevOps lifecycle. So let's explore our new announcements and why we believe they provide solutions to these challenges. First, we know developers need to work both online and offline. So today, we are announcing the public preview of the Azure SQL Database local development experience. We will now allow you to develop and test databases locally, publish updates through CI/CD pipelines, and support Workstation or GitHub Codespaces environments. We will do this through a set of Visual Studio Code extensions and an emulator for Azure SQL Database using containers. Second, developers tell us they love Azure Functions because it gives you a serverless solution to use with cloud applications. Binding data in Azure Functions has been challenging, so we are excited to announce the public preview of Azure Functions integration with Azure SQL Database, which includes SQL input and output bindings and support for .NET, Node.js, and Python. Next, we know JSON data is everywhere, and if developers want to use T-SQL, it must provide capabilities to process JSON data. So we now have in public preview new and enhanced T-SQL function support for JSON capabilities. These JSON functions are supported in both Azure SQL Database and SQL Server 2022. And finally, developers are looking for innovative methods to integrate data with other services. Since most services support REST endpoints, you can now use stored procedures in Azure SQL Database to push data from the SQL engine with T-SQL to just about any REST endpoint you can think of. This enables you to use the power of T-SQL to push data within the engine to ML services, Event Hub, or any REST endpoint you create. You can even activate workflows for Azure Logic apps or notify SignalR websites, all integrated with your SQL code. Hey, sign up today for our EAP program at the URL you see on your screen. Is it possible to build an application that shows all of this new innovation together? Well, the answer is yes. And Drew Skwiers-Koballa is here to show you how.
Thanks, Bob. I have a demo to share that brings together some great new features for developers working with Azure SQL Database. The demo will take us inside the development process of working with both existing apps and building new apps. This is Contoso Insurance's customer chat dashboard, an app they built on Azure SQL Database to improve their ability to provide on-demand customer service to customers that need assistance. With the development tools available for local development and CI/CD for Azure SQL, developers working on this app were able to collaborate across Windows, macOS, and Linux while shipping seamlessly from GitHub Actions. The app integrates with several services, including third-party apps, through new features in Azure SQL Database for developers. Let's take a look. To handle customer inquiries on their website and mobile app, Contoso Insurance purchased a chatbot specific to the insurance industry and connected it to an Azure SQL Database. Since the customer chat is protected by an append-only ledger table in Azure SQL Database, the Contoso Insurance developers extend its functionality by using SP Invoke External REST Endpoint to trigger a REST API whenever a row is added to the transcript table by the chatbot. SP Invoke External REST Endpoint is a new stored procedure in Azure SQL Database, creating the ability to call out to a REST endpoint from the database. Contoso Insurance is able to send the chat contents to an Azure Durable function, which returns to the database immediately while orchestrating the processing of the chat contents with Azure Cognitive Services for key phrases and sentiment. With Azure SQL bindings for Azure Functions, exchanging your data with Azure Functions in C#, JavaScript, and Python has never been easier. By writing the chat's detected sentiment and key phrases back to the database, we've enriched the data from our chatbot. The Customer Chat Dashboard is an Azure static web app, and it uses the integrated Azure Functions with SQL input bindings to pull data from Azure SQL, such as the active customer chats. To enable Contoso Insurance customer representatives to hop into the chat and assist a customer as quickly as possible, new chats are pushed to the dashboard via SignalR-based notifications. By calling a SignalR endpoint from Azure SQL with SP Invoke External REST Endpoint, we can pop up a toast notification on the dashboard and update the visualizations. We have a customer on the Contoso website interacting with the chatbot, But the key phrases and sentiment detected in the conversation are cause for alarm, and the customer service representatives need to know. In real time, a notification appears in the upper right corner of the page, and a row is added to the top of the table. Contoso Insurance wants to display their customer satisfaction, or CSAT scores, based on customer feedback after chat interactions on the Contoso Insurance customer dashboard. The query for the report is represented by a very brief stored procedure. Contoso Insurance developers can add a stored procedure to the SQL project in VS Code and deploy this to an Azure SQL Database local development container for testing while building the front-end components. After quickly adding the stored procedure, we will build and publish the SQL project locally to an Azure SQL Database local development container. When publishing a SQL project, it can be an update to an existing database or a completely new development container instance. Advantages of SQL projects for your database development include the ability to set variables that are evaluated at deployment, perfect for endpoint values used by SP Invoke external REST endpoint. During publish, the container image is pulled and started before the database schema in our SQL project is applied. We'll wait just a few moments for the image to pull and the schema to deploy. Great. With our SQL project deployed locally, we can see the whole schema, including the stored procedure we just created. Now we can work on the front end. To add an API to the Azure Static Web App for displaying the last 5 months of CSAT scores, we will create another Azure function and use a SQL input binding. The SQL input binding that we add to this function executes the stored procedure we added to the database and places the result in a C# object available for use in the function. Within the function, we're able to handle the result or manipulate it to present it as we would like to consume it on the front end. In this scenario, we're augmenting the information in the database by adding information about the background color associated with different CSAT scores. So for every row in the results, we will apply a different background color. We can test the Azure Functions locally using the Azure SQL Database local development container and the Azure Functions local runtime. In hitting F5 to run the Functions runtime with the local container as our SQL connection string, we'll be able to run the function endpoint on our development machine. It's great to be able to verify and test before checking in changes and deploying with GitHub Actions. The deployment pipelines we have set up encompass the SQL project changes, where we've set the SQL CMD variables to our production endpoints. We'll now merge in our changes, and the deployments will kick off to Azure Static Web Apps and Azure SQL Database. We can see SQL Action building the SQL project and then deploying it to Azure SQL Database right from GitHub. Great, our changes have deployed. Once we refresh the page, we have visibility to our customer satisfaction scores. We can see the improvement in April when we introduced the Azure SQL-powered chat dashboard, enabling the customer service agents to better help customers. With help from SP Invoke external REST endpoint in Azure SQL Database, we were able to seamlessly extend the chatbot we purchased for our website. As developers, it was fantastic that with SQL projects, we can create Nuke local environments on the fly. Whether creating APIs for data access or to enrich our data, using SQL bindings on Azure Functions made quick work of the challenge. As we saw in working on Contoso Insurance's customer chat dashboard, there's a lot of flexibility in the integrations between Azure SQL and Azure Functions. SP Invoke external REST endpoint is now in private preview, and SQL bindings for Azure Functions is now available in public preview for C#, JavaScript, and Python. Now let's head back to Bob.
Thanks, Drew. That was truly an end-to-end scenario showcasing all our new announcements. You know what's most compelling about these is they address common challenges for developers. We want Azure SQL Database to be the preferred database developers platform, so expect even more innovations from us in the future. We are also excited today to announce the general availability of Azure SQL Database Ledger. Also available in SQL Server 2022 as a public preview, Ledger is built into SQL and includes ledger tables to track and audit modification history or modifications to data. Updatable ledger tables are perfect for protecting sensitive traditional SQL data for auditing and compliance purposes. These ledger tables have automatic history and a ledger view to see all modifications and who made them. Ledger comes with built-in crypto hashes of transactions for data protection in the form of a blockchain. In addition, database digest, a hash of the blockchain, are stored separately to provide an independent verification of the data. Ledger tables can also be append-only, which is a great choice for multi-party trust verification of data. Let's look at an example where SQL Ledger can help business partners trust each other's data without a central authority, like blockchain, but using a centralized database like Azure SQL Database. Consider a company that produces ice cream. They need a centralized system where all the business partners can trust data critical to the shipment of ice cream, like temperature. Here is a Power BI dashboard that tracks temperature across the various partners in the supply chain. I can see from the data that there is a Celsius temperature problem affecting the quality of ice cream. The data shows it appears to be one of the shipping companies. I need SQL Ledger to show this data is valid and can be trusted by all partners. In order to store our shipment information, we're going to use Azure SQL Database. In this database, I have a table to track shipments as part of the supply chain. And some of the columns in this table include who's responsible for this part of the shipment of the supply chain, what is the temperature of the product, and is the temperature out of compliance for the needs of our business. Well, how do you use SQL Ledger? You just use a simple syntax to the table definition, and you can make it append only, which means only data can be inserted into the table and not tampered with. What if somebody tried to go into the database and modify the temperature that was out of compliance and make it look like it was in compliance? So first of all, we can select this table and see that part of the supply chain that was out of compliance matches our Power BI dashboard. It's this shipping company with this temperature, and that temperature is out of compliance for the needs of our supply chain for ice cream. So if somebody with DBA rights could go into this system and run a simple update to try to take that same shipment and change the temperature and change the fact that it's now in compliance. But because it's an append-only ledger, that is not allowed. That is one of the powerful features of SQL Ledger, is not allowing people to tamper with data that is marked append-only. One of the great things about Ledger that is built into the system is a ledger view. It includes information about data from my table, but also includes details about what type of transactions were applied against the shipments table. In addition, there's a system view that stores transaction details about all the ledger tables in the database. I can join between them with a transaction ID. And in the system view is when a transaction takes place and what SQL principal is responsible for the operation against the ledger. You can see from the result here, since it's an append only, all of my transactions are only insert operations. SQL Ledger internally stores crypto hashes of all transactions, including a chain of blocks, hence blockchain. In addition, SQL Ledger supports a hash of the latest block in the form of a digest. Azure SQL Database supports an automatic process to keep digests in a separate trusted location. Now, at any point in time, any partner in the supply chain can verify the ledger has not been tampered with using digests and built-in verification. We have now achieved our goal of trust without a central authority using a centralized system like Azure SQL Database. Now you can see how SQL Ledger brings tamper evidence records and data protection all built into Azure SQL Database with a simple table declaration. SQL Ledger is also available in the public preview of SQL Server 2022. A trusted supply chain is critical for manufacturers, and Lenovo is a company that is already seeing the value of Ledger for their business. We expect to see more and more examples of how SQL Ledger can empower businesses for trust of data. The last topic I'd like to talk about today is data analysis. Microsoft Purview is a central hub for insights and governance. And I'm excited to announce the public preview for dynamic lineage for SQL. We've seen that root cause analysis for issues with your data is tough. For example, using static analysis to look into issues with SQL code isn't comprehensive enough and can be very manual, which means time and cost. The solution is dynamic lineage for SQL. This includes if-then analysis to determine when did code fail or succeed without any scanning. Purview can give you quick answers on exactly when code has been executed and its status. Finally, seeing the impact of how many rows are affected by various operations can give you insight into expected execution and even possible performance impact of your SQL code. Every time I see a demo of dynamic lineage, I want to try it on my own code. So here is Sunetra Virdi to show you some compelling examples.
Thanks, Bob. It's a pleasure to be here, and I'm excited to demo the power of dynamic lineage in Microsoft Purview. Let's look at the scenario. Andy is the data analyst for Contoso Corp Retail, and he is building a quarterly sales report for the CEO of the company. He comes into Purview and looks for a reliable source of data. He types sales in the search bar and sees there are sales tables available. He clicks on Sales Q222. Schema looks useful for his report, but there is no lineage. He doesn't know how the table gets populated. This doesn't seem right. So Andy goes back to search results and clicks on Sales Q122. Looks like this table has a schema and it has a lineage. The table takes dependency on a stored procedure. He switches context to the stored procedure, clicks Properties, runs, and here he sees the procedure was executed with a parameter value of 1. The procedure was also updated in April, so does not make sense not to generate a Q2 sales table if this is the right procedure. Something is not right, so Andy decides to follow up with the data owner Fortis to further investigate. Fortis is the data owner of the stored procedure. He looks at the procedure and finds that it has 2 branches, each loading a different sales table. Based on the information that he received from Andy, only sales Q122 must have been loaded. Fortis executes stored procedure again and asks Andy to check Contoso Purview in a few minutes. Andy comes back to Contoso Purview and again searches for sales, clicks on Sales Q222 table, checks lineage, and voila. The table is now mapped to the stored procedure, which means the table is loaded and he can take dependency for his report. So as you can see, with the help of dynamic lineage in Purview, you can see which branch of the stored procedure was last executed and its execution time, making analysis far easier than what's offered with static lineage. And now, back to Bob.
Thank you, Sunetra. I think you can now see what is possible with Microsoft Purview. Purview has so much more to offer, including data insights, data classification, and policy management that can extend across all your SQL assets and data estate. Before I leave you, I want to make sure you know about some other great related sessions here at Build. Don't forget, one of these is a chance to ask the experts immediately following this session. Wow, we have covered a lot, including a bunch of new announcements with great demonstrations. We showed you all the new innovations for SQL Server 2022, now in public preview. Some incredible Azure connected capabilities, along with built-in query intelligence, and core engine features for security, scalability, and availability. We talked about the ability to achieve near real-time analytics without affecting your operational workloads with Synapse Link for SQL, now in public preview. Then, we covered some incredible announcements for developers for Azure SQL Database, a new local developer experience, integration with Azure Functions, new JSON functions, and HTTPS endpoints from the engine. We also showed you the power of Azure SQL Database Ledger now generally available. And finally, Microsoft Purview is a central hub for data, and that includes the public preview of Dynamic Lineage for SQL. I hope you're as excited as I am about everything happening with SQL. Please use these resources to learn more. Thanks so much for attending today's session, and I hope you enjoy the rest of Build 2022.